Hey guys, this is Script. I just wanted to go over a couple of problems from the recent quiz and just review a little bit. And it's numbers 13, 14, and 15, but it's really one question, and I just kind of broke it down into questions. And I changed the way I asked it depending on when you took it. I tried to improve it. But the question was, a sample of 32 mils of hydrogen is collected by water displacement at a temperature of 25 degrees Celsius. The barometer reads 652 torr. What is the volume of hydrogen at STP? So there's a couple things right here. This by water displacement is kind of the key to this. So I'm going to go back over here. This is the reference sheet. And so whenever you see the words by water displacement, you're going to need to use the reference sheet. Okay, so here we are. If you see the words by water displacement or collected over water, you're going to need to use this water vapor pressure chart right here. And you're going to need to look up the temperature. And so let's go back to the question real quick. So we had a 32 mil sample of hydrogen, and it's collected at 25 degrees Celsius. So let's see here. I'm going to just write the information here. 32.0 mils of hydrogen. And it's collected at 25 degrees Celsius. And what else did it say? And the barometer reads 652 torr. And they want to know the new volume and STP. So we have 652 torr. And they want to know the new volume at STP. Okay, so that was all the pieces. Now we had a volume here. And that's going to be your volume 1. And this is going to be your temperature 1, the 25 degrees Celsius. And then we have to figure out pressure. So let's write, volume 1 is 32.0 milliliters. And then temperature 1 was 25 degrees Celsius. And we had to convert it to kelvins. So we add 273. So there's my real temperature 1. And then my pressure. Well, I'm given 652 torr. Oops, I wrote 25. 652 torr. But it says on the question, here it goes, by water displacement. So 652 torr was by water displacement or collected over water. So that means that we had sort of a picture like this with our container, and we have water here, liquid water, but we have water vapor flying around up here. I'm going to write little H2Os for you. And those are little water vapor molecules. And then we have the molecule of hydrogen that we wanted. We want hydrogen gas that's flying around, and hydrogen's diatomic. We want just the hydrogen, just the diatomic hydrogen. We want to get rid of the water. So to know what the pressure is inside here, this is the total pressure. That's what the 652 is. This is the total pressure. So I want to know what the pressure of just the hydrogen is. So I'm going to have to subtract out the water vapor. So what I do is I find the temperature that I was given, 25 degrees Celsius. So I go and find 25 degrees Celsius. And I was given this pressure in torr. So I go and try to find torr. Well, I didn't give you torr. But if you'll notice, right above here, 760 torr, 760 millimeters of mercury. So they're the same. You could just use this one as torr. Okay? So you go find the water vapor pressure in torr. So it's 24.0 torr. And that was really the first question on this. What is the vapor pressure, or what is the water vapor pressure? Water vapor pressure at 25 degrees Celsius. It was just 24 torr based on this right here. So I'm going to now have to subtract out that 24 torr from the 652, and I get 628. Okay? 628. 628 torr is my real P1. So that is the adjusted pressure. So I think the next question said, what is the adjusted pressure for P1? And I even said here, remember, subtract the water vapor pressure. So there's your new pressure. So now I know V1, T1, and P1. And then V2 is my question. And then T2 is at STP. Remember, STP is standard temperature and pressure. So standard temperature is 273 kelvins, and standard pressure, well, the standard pressure is 1 atmosphere, or anything that equals 1 atmosphere. So here's 1 atmosphere, 760 torr equals 1 atmosphere. And I'm putting it in torr because I want my units to match. So now I have 2 V's, 2 T's, and 2 P's. And so the only formula that has 2 V's, 2 T's, and 2 P's is this one right here, the combined gas law. So that's the formula I use. So I'm going to write P1V1 over T1 is P2V2 over T2. And I cross multiply, take the time to do this. So P1V1 T2 equals T1 P2V2. And then I'm trying to find V2. V2 is my question. So I'm going to isolate V2 by multiplying both sides. I'm sorry, isolate this V2 right here. So I'm going to divide both sides by T1 and P2 so that they cancel out. So now I have V2 equals these things. P1, V1, over, and T2 divided by T1 and P2. So look for P1. There's P1. 628 torr. V1 is 32 milliliters. And T2 is 273 kelvins. Divided by T1. T1 is 298 kelvins. And P2 is 760 torr. And now all you have to do is cancel out your units. So torr and torr cancels, kelvins and kelvins cancel. Milliliters is what left, and V2 is going to be in milliliters, which is my volume. And when I do that, I put it in my calculator. Pull up my handy dandy calculator. All right. And we have 628 times 32 times 273, enter, divided by 298, enter, divide again by 760. I get 24.22, and that's kind of a raw answer. And then we got to look at sig figs. All right, this is a true answer, so that's 3 sig figs. This is 3 sig figs. This is 3 sig figs. The 273 actually don't count because that's the standard temperature and pressure. So, but I ended up rounding this to 2 sig figs. I would have taken 3 sig figs is actually the more correct answer, 24.2 milliliters, because all these measured values at the beginning had 3 significant figures. All of those had 3 sig figs. So this is the better answer, 24.2 milliliters. Okay, that was missed a lot. Okay, that's one of the questions that I wanted to go through. And then I want to go through a stoichiometry question. So hold on. Okay, so I wrote a stoichiometry question for you. I went ahead and gave you a balanced equation right here. And I'm telling you that you have 38.7 grams of water that has been produced. So that's going to be your A, the thing you know. And I'm asking for how many liters of oxygen. So that's going to be your B, the thing you don't know. Now I wrote up here the pathway that we've had before, and this is something you might could write on your 3x5 card. And we've done mass to moles, moles to moles, and that's using the ratio B over A. Remember, the one you need over the one you know. And we had to use molar masses to change from mass to moles or back from moles to mass. We still use the molar mass. Now we're going to use the molar volume, which is 22.4 liters are in 1 mole, or 1 mole is 22.4 liters. Remember, this molar volume is only good at STP. You can only use this when you have standard temperature and pressure. So we're going to assume we have standard temperature and pressure because I asked you for the volume. So remember, with stoichiometry, you start with what you know. We have 38.7 grams of water. All right. So what we're doing is we're starting where we know we are. We have this our A. And we have to get to moles of A using the molar mass. So I need the molar mass of water. And I chose this one because this one was missed a lot on the last test. H2O, 2 hydrogens, 1 oxygen. So you have to multiply it by the molar mass that you get off the periodic chart. And so then you add these together. You get 18.02 grams per mole. That's the molar mass of water. So 1 mole on top and 18.02 grams on the bottom. Okay? So that brings us to the next step. So this was the molar mass right there to get us to the moles. Now we're at the moles of A, and we need to get to the moles of B using the ratio. So I need the B over A ratio on the next step. Now remember, the ratio comes from the coefficients, these numbers right here, right in front of the molecule. And the B is what I want to go first. Now in this case it's a 2 to 2 ratio. But if I said, what's the ratio of hydrogen to oxygen? It's 2 to 2. What's the ratio of, water to oxygen? What is it, water to carbon dioxide? It would be 2 to 1. Or what is it, carbon dioxide to water? It would be 1 to 2. You got to put it in the order that you're asked. So your B is oxygen, so you put 2 moles of oxygen are needed to create 2 moles of water. And so now your B over A is done. And I'm going to go ahead and cancel a couple of units. Grams can cancel, water can cancel, and one of the moles can cancel. So I have moles. I'm at moles now. But the question is asking for liters, and liters is volume, a volumetric unit. Volume. Liters, milliliters, centimeters cubed, those are volume units. So I'm trying to get to here. That means I use the molar volume. And I wrote it in this form, 22.4 liters over 1 mole, because I'm turning it into liters and I'm getting rid of the moles. I don't have to calculate molar mass. All right, so now I just have to do the math and get an answer for this. Okay, so I'm going to go ahead and put it in my calculator. 38.7 divided by 18.02. And then you'll notice the 2's can actually already cancel, but I'm going to just multiply and divide by it. So times 2 divided by 2, and then times 22.4, and I get 48.10. 3 significant figures because the first value is where you get them, 1, 2, 3. So it's 48.1 liters. That's the final answer, 48.1 liters of oxygen, of O2. So that's the stoichiometry, and you just need to be careful with that. All right, I hope this will help you, and I will see you soon.